Hello and welcome to Empowered Learning. This video will be about taking an example of a problem that we model using linear programming and then using sensitivity analysis to ask what-if questions so that we can figure out how those questions would actually affect our solutions, if they affect them at all, and if our solutions stay the same, how our objective function will change as a result of that. So this example that we have here is of a electronics company called Anderson Home Electronics. And so this company makes MP3 players, satellite radio tuners, LCD TVs, and Blu-ray DVD players. And so to make this simple, we are saying that in order to produce these four items, we have everything categorized in terms of electronic components, non-electronic components, and assembly time. And some of the information that we know is that for each electronic component, we're saying is going to be $7 per unit. The non-electronic component is going to be $5 a unit, and assembly time is $10 an hour. So to put this into perspective, when we say the electronic component, we're basically saying that in order to make these four products here, we've negotiated with our subcontractor that supplies us all the components that we need to be able to make these products. And so we've probably made a deal here to where we're selling a set number of electronics as a bundle. And for the electronic ones, that will be $7 per unit, so per bundle. And the non-electronic components, we also have those as well. We probably have that in a bundle package as well that's negotiated, and that would be $5 for the entire bundle. And then of course assembly time is just going to be how much we pay either our workers and or how much it costs our automated machines to be able to put these devices together. Okay. Now for the selling price, for each of the products, of course, the MP3 player is $70, LCD TV is $150, satellite radio tuner is $80, and Blu-ray DVD is $110. So this is the information that we're given here. Now, if we look at all this, I've stated stuff about the electronic components, non-electronic components, and assembly time over again, and the selling price. But what we see here below this table really gives us a good idea of what we actually have available to us. So if we look here, we see that for the electronic component units, for the MP3 player, we need 3 of those. We need 2 non-electronic component bundle units, and we need 1 hour of assembly. And for the satellite radio tuner, we have 4 of these electronic component bundles, 2 non-electronic component bundles, and 1 hour of assembly time. For the LCD TV, we need both 4 electronic and non-electronic components and 3 hours of assembly time. And for the Blu-ray DVD, 3 hours of, 3 electronic and non-electronic component bundles and 2 hours of assembly time for that. Okay. And so we know that for the electronic components, we have a total of 4,700 units, total of non-electronic components of 4,500, and the company can afford 2,500 assembly time hours to pay the workers there. Okay. So this is what kind of constraints we have. So if we put all this together and actually try to model it, so of course we're going to define what our variables are going to be. So if we do that, you'll see that this is what it ends up being. So I'll go back a slide here so that we can do this. So we're calling M the variable for the MP3 player, so the number of MP3 players that we make. We'll do S for the number of satellite radio tuners. We'll do T for the number of LCD TVs, and we'll do B to represent the number of Blu-ray DVD players. Okay, so if we look here, we know that for our constraint as far as doing the, I guess, the supply of electronic components, we know we got 3 times the number of that, plus 4 times the number of the satellite radio tuners, plus 4 times the number of LCD TVs, plus 3 times the number of Blu-ray DVD players, and at most what we have for electronic components is 4,700, so that would be a less than or equal to. Same thing will be for the non-electronic components and assembly time. So we did all this. That's plus. That will be less than or equal to 4,500. And then for the assembly time, 1 hour, 1 hour. That will be plus for both of these. 3 hours for this, 2 hours for that. We have to stay under or at 2,500. And then of course, the selling price, we want to make the most amount of money that we can. So here we know that this is going to be the revenue for all of this. And if our goal is to make as much profit as we can, then we would want to take revenue and subtract cost in order to make profit. And so you can see for these 3, this is how we get the inequality for the electronic components, non-electronic components, and assembly time. For here, we get this because we know that all of these values have to be greater than or equal to 0, meaning that we won't be making a negative amount of MP3 players, satellite radio tuners, and LCD TVs or Blu-ray DVD players. All right, so one thing I want to go ahead and correct here, this shouldn't be 2 pluses, this should just be 1. So I'm just going to get rid of that there. Now, the other thing that you're probably wondering about is the objective function. If we want to maximize profit, then how do we come up with this 29? How do we come up with this 32, 72, and 54? So we're going to go back and actually see how we do that. Now, of course, I mentioned earlier that profit was the difference in between revenue and cost. So we'll just look at the MP3 player there and kind of come up with what we have here. So we notice here that the electronic components, non-electronic components, and assembly time all are going to be cost to make this particular MP3 player. Okay, so if I know that the selling price per unit is $70, then $70 times M is going to give me the actual amount of money that I'm going to make. So here my revenue here will be 70M. So 70 times the number of MP3 players I actually sell. My cost, however, it's going to be a little different. So here it takes me 3 electronic components, and I know that each electronic component is $7 a piece. So that's going to be basically 3M times 7 because of the $7 per unit. My non-electronic components is 2M, but of course it cost me $5 for that. So that's going to be 2M times 5. And then the assembly time is $10 an hour. And so for the assembly time for the MP3 player is just 1 hour. So this would be 1M times, didn't go so well there. So 1M times 10 basically. So let's try to redo that. So 1M times 10. And of course, 3M times 7 is 21m minus 2m times 5 is 10m minus 1m times 10 is 10m. So 21m plus, this shouldn't be minus, this should be plus, because all this is together. So all this is the cost. So we'll do pluses there. So if we add all that up, we get 41m on the inside there. And we rewrite this to write this correctly. So that will be 70m minus 41m, and that ends up giving me 29m. So that's how we actually come up with, go to the next slide here, the 29m for the amount of profit that we receive off of each MP3 player. Now, of course, if we did the same thing for the rest of these, we'll see that we get 32, 72, and 54 respectively. So I'll do one more just to make sure that we get it here. So I'm going to go ahead and erase. Let's see if I can erase this here. All right, so again here we see that we're going to have profit is equal to revenue minus cost. And for the satellite radio tuner, we know that revenue in itself is going to be 80 times the number of satellite radio tuners that we make. So here, I should have put a S there instead of an M. Okay, and for the cost, we know that is going to be 40 electronic components at $7 a piece. So that's going to be 28S. And then in addition to that, the non-electronic components, we have 2 of them at $5 a piece. So that's 10S. And then we have 1 hour of assembly time at $10 an hour. So that's 10M. And of course, when we total that, that's going to be 28 plus 10 is 38. 38 plus 10 is 48. And so our profit here is just the difference in between 80S and 48S. And of course, 80 minus 50 is 30. But of course, we got 48, so that's 2 more than that. So that's how we end up with the 32S there. And if we look, that's exactly what we see here. And if we did the other two, the LCD TV and the Blu-ray DVD player the same way, that's exactly what we would get. Okay. So we've done all this to basically say, here is our maximizing profit objective function, and we know that we have these constraints here. And of course, if we were to actually set this up in Microsoft Excel, this is what it would look like. And these are the solutions that you would get as a result. And so one of the things we want to take note of here is that in order to achieve maximum profit here, notice that it's telling you that for MP3 players, you won't be making any of these, and you won't be making any LCD TVs. So as we look at this, we see that we're only in the business of making satellite radio tuners and Blu-ray DVD players if we want to maximize profits. If we're in a situation where we really need to sell all of them, even though we know that that doesn't achieve maximum profit for us, then we need to ask some questions about our situation to see what kind of flexibility we have. Okay? And here this just goes through the process of figuring out how to put everything into the Excel solver and getting the right cells to go where they need to. I'm not going to spend a whole lot of time on this because I actually go through that in some of my previous videos. If you are having questions about this, you can check out my videos on linear programming using the Microsoft Excel solver, and that'll answer those questions for you. Okay. So once you actually run the Excel solver and you get a solution, you will have the option of selecting to have an answer report and a sensitivity report be formulated for you. And so this is the example of what the answer report will give. And so all that the answer report is doing is, of course, telling us what our profit was. The original value was 0 before we ran the solver. And we see now with the current solutions that we have, that profit will be $69,400. And to get that, we're going to have to make 380 satellite radio tuners and 1,060 Blu-ray DVD players. And we have to refrain from making any MP3 players or LCD TVs. Okay? So we also see down here below that for the electronic components here, we see that we have used up all of our electronic components to achieve this maximum profit. We also see that we have used up all of our assembly time. But notice that for the non-electronic components, we have some slack. In other words, for the non-electronic components, we did not use all of them up. So this is what we call a non-binding constraint. So in other words, for the electronic components in assembly time, if we were to change the amount of electronic components that we had or change the assembly time, that's going to change our feasibility region for our linear programming system here. Okay. Whereas for the non-electronic components, as long as we don't use up that extra 560 that we have available to us, then we're fine. So basically, we could reduce the amount of non-electronic components that we need by 560 units, and it still wouldn't change our profits in. Okay. So this is the type of information that the answer report gives us. For the sensitivity report, we see that we have a couple of things being shown to us. So first thing is we see that we know what our final value is. So in other words, the solutions for the number of MP3 players, satellite radio tuners, LCD TVs, and Blu-ray DVD players. Notice here that everywhere where you see the final solution here is 0, we're given a reduced cost. And so a reduced cost is also called an opportunity cost, meaning that if you wanted to actually produce MP3 players and LCD TVs, you're going to have to sort of take a loss in profit to be able to make that happen. So that's one interpretation. So put it in another way, for every MP3 player that we want to produce, even though we're not going to achieve maximum profit by doing that, we're taking $1 profit away from us. Away from what our maximum profit would be for every one of those that we produce. Similarly, for an LCD TV, every time we produce one of those, given our current constraints and situation here, we are taking away $8 of profit from us, from whatever the maximum profit is. So that's one way to interpret that. Another way to interpret what we're saying here is that in order for us to be able to produce an MP3 player, we somehow have to come up with this dollar difference in profit. So that means either we're going to have to increase our profits by $1 or reduce our cost by $1 in order to have it make sense for us in our situation here to produce MP3 players. So to be more clear on what I'm saying, all right, so here, do you see our objective coefficients? So here right now, this 29 actually represents the amount of profit that we're making per MP3 play. From our current situation, what this is saying is that, hey, this $29 per MP3 player profit is not enough. So in order for it to make sense to produce an MP3 player, we either have to get this 29 to 30. So we have to get this from 29 to 30 by doing one or two things. Number one, we would have to go and increase the price of our MP3 player. And if you remember, let's go back here. The selling price of our MP3 player is $70. So we would have to increase the price from $70 to $71. Now on the other end, the other thing that we would have to do is to take the cost, which is $41, and decrease that by $1. So here we would have to go from $41 down to 40. So we go up this direction, go down this direction. In both cases, we see that we're reducing either the cost or increasing the selling price by $1 to make up for that difference, so it'll actually make sense for us to produce the MP3 player. So that is getting back to where we were. So that's what the reduced cost is telling us. Of course, for the LCD TV, we see that the reduced cost is $8. So if we come back here, that's telling us that we're either going to have to take, we got to take this profit here of $72, and we're going to have to increase that to $80. And we can do that one or two ways. We need to take our selling price here, which is $150, and bump that up to $8 there. Or we could take our cost, which is $56, and reduce it by 8, which will give us $48. So down here, up there. Either one of those cases would get it to where profit, the amount of profit that we have, is enough to start to make sense on being able to produce an LCD TV here. So that's what the reduced cost is trying to communicate to us. Now for the satellite radio tuner and Blu-ray DVD, we see that the reduced cost is nothing for these because we have enough profit going on to where it makes sense. Now, to keep these solutions that we currently have the same, we know that the allowable increase for this is only $1. And of course, that makes sense because if we increase our profit by $1, then of course now it makes sense for us to actually start to produce MP3 players and not necessarily keep it at 0. Okay. Now on the allowable disc decrease, this is saying that you can decrease as much as you want, but you can only increase this amount to be able to change these solutions here. Now for the satellite radio tuner, we see that the allowable increase is going to be 40. So in other words, as far as increasing the amount of profit, hey, we got a lot of room to do that. But on the low end, we can only go down $1.67. Okay, so what that means here is that for satellite radio tuners, if our cost goes up any, we got a huge problem. If it goes up beyond $1.67, then we're going to start to erode from our profits in such a way to where it's not going to make sense for us to make satellite radio tuners. And of course, what we would try to do to start off is increase the price, but if our market doesn't support that increase in price, then we're going to have to either go to a different supplier or something like that so that we don't go under that $1.67 threshold. Okay. Now for, again, the satellite, not the satellite, but the LCD TVs here, we see that the allowable decrease, we can go as low as we want to, but the allowable increase is only $8. So again, we would have to get our profits up to at least $80 per LCD TV in order for it to make sense for us to do that. But of course, if we decrease, we're saying that, hey, to keep these same solutions here, your profit could be as low as it wants. But, you know, if you actually want to start making this device, then you're going to have to go up to at least $8 here, okay? And then, of course, for the Blu-ray DVD player, we see that the allowable increase to keep this amount here and to keep these solutions the same, the profit the same. We can increase profits up to $10, but we can only go down $5, okay? Now down here for our constraints, we see that these are our final values here. And so we see that we've used up all of the electronic components and used up all the assembly time. But notice that we did not use up all of the non-electronic components, because we see the difference in between these two numbers here. And of course, that difference there is the 560 that we see here in the allowable decrease. Now, the shadow price, what this is, we are talking about the price or the amount in profit that we will add to or take away from if we change any of our right-hand side constraints by 1 unit. So for instance, if I wanted to change the amount of electronic components I have from $4,700 to $4,701, $4,701 unit, then when I change that supply amount, this tells me that my profits are going to go up by $2 for every 1 electronic component I have extra in supply. And of course that works the other way. So if I do this, I am going up $2. Now, if I went the other way and went down to, was it $46.99, then I'm going down $2 in profit. So if I take away one of those electronic components, let's say I have a faulty one and I have to throw it away, then of course my profits are going down by $2. Granted, everything else stays the same. The assembly time, you see, this is huge. So we're saying if I was to add, let's say 1 hour of assembly time, my profits go up by $24, provided everything else is the same. But if I go down 1 hour of assembly time, then I lose $24 in profit. Okay? So we see here for this situation, the assembly time, we want to closely watch that more so than the electronic components. For the non-electronic components, we don't have a shadow price because, of course, we didn't use up all of the components that we have. So we have some slack, and we have slack of 560 units here. So that's not really going to affect our profits in. Okay? All right, and so we've already talked about the reduced cost or opportunity cost. Again, the way that it's put here is to say the difference in between the cost to invest in producing a product versus the cost in producing an alternative product, okay? And I just said it another way. So all I've said is, how much is it going to cost you in this case to increase your profits to where it actually makes sense for you to start producing that particular item versus another item, okay? Now it says the minimum amount, the respective objective function coefficient of a variable should change in order to affect the optimum solution. So this is more of the approach that I took. All right, so now what we're going to do is our what if analysis. So we're going to ask these questions, and based upon what these questions are, we're going to go back to our sensitivity report, and we're going to answer these questions. So I'm going to go ahead and clear this because we'll be going back and forth from the questions to the sensitivity report pretty often. to be able to answer these. So I'm going to go ahead and pause right quick and clear all this, and then we'll start with our questions. All right, so now we're at our questions here. So we're going to start doing our what-if analysis. So the first question is, what is the impact on profit of a change in the supply of non-electronic components? Okay. So of course, this question here. Now, of course, if you remember, the non-electronic components was the one that we had some slack for. So if we go back here, non-electronic components, we see that we actually used up 3,940, but we had up to 4,500 to use. So since we see here we have no shadow price, what that's telling us is that this is a non-binding constraint here. So this means that we're not going to have any effect on profit here. Okay. So if we go back to our question, it says, what is the impact on profit of a change in the supply of non-electronic components? So here, the answer to this, it's no impact for supply that is going to be supply difference of 560 or less. Okay. So basically what I'm saying is that as long as we don't go below this 3,940, as long as we don't go below that, then we're fine. Okay. Now, of course, if we get below the 3,940, then it will change. But according to what we currently see, there is not going to be a change as long as we don't go below 500, or go below 3,940. Of course, we can increase it as much as we want, but we just can't go below the 3,940. Okay, so that is the answer to the first question here. So the second question says, what is the impact on profit if we could increase the total supply of electronic components by 400 units? Okay, so basically, if you remember here, the number of electronic components we had was 4,700, and we want to move them up to 5,100, which is a difference of 400 units. So if we go back to our sensitivity report, you see for our electronic components, if we were to increase this by 400 units, here we have a shadow price of $2. And so the shadow price tells us how much we're going to change in profit, whether increasing or decreasing based upon a unit change in the value here. So we know here that we want to change 400 units, and our shadow price is $2 a unit. Excuse me. So the result here is going to be a total of $800 increase in profit. So our profits are going to go from what they were, and I'll go back to that. So our profits here, 69,400. So we're going to add 800 to that, and so now that's going to be 70,200 if we actually were to increase the number of electronic components that's available to us. Okay, so that is the answer to the second question. All right, so that one's done. So we say in the previous question, which was the one that we just got through answering here, and by the way, let me go ahead and put here, we'll just say 800 increase in profit. Let's do that. All right, so for the third question, it says, in the previous question, what would happen if we could increase the supply of electronic components by 4,000 units? Okay. So in other words, we're trying to go from here to now here. So what would happen? Okay. So let's go back to our sensitivity report and see what would happen. Okay. So if we wanted to change this from 4,700 to 8,700, then what would happen, of course, is that the profit is going to increase a lot. But the thing is, if you look at our allowable increase and decrease range, we can only increase up to 2,800. Okay, since we have a total of 4,000 units that we want to increase this by, we're not going to be able to account for all of them. So to start off with, we know that if we increased 4,000 units, the first 2,800 extra units, we would multiply that by the $2 shadow price, and we would come up with $5,600. And so we would have $5,600 increase in profit, but for the remaining 1,200, because of course we know 4,000 minus the 2,800 is 1,200. For the remaining 1,200 units, we really don't know, because that's outside the scope of what the sensitivity report says. If anything, we know that at this point, if we wanted to add any more than 2,800 units, this would actually affect our our optimum solution here. So that means that these values would actually change. And it doesn't necessarily mean that we would be producing MP3 players and LCD TVs, but what it will say is that there's going to be a change in the number of satellite radio tuners and a change in the number of Blu-ray DVD players that we're going to make if we have that big of a jump in the amount of electronic components that's available to us. Okay, so in short, we know that the profit will go up at least $5,600, but for the remaining 1,200 units that the sensitivity report does not let us know about, we really don't know what's going to happen. So that's you're seeing a limitation of the sensitivity report here. Okay, so let's move on to the fourth question. All right, so I'm going to move on to here. We'll say increase 5,600. Question about the additional 1,200 units. We don't know how that will change. Okay. Now, for number 4, it says, refer to the question about getting an additional 400 units of electronic components. And so that would be question number 2. It says, what would happen if the supplier of these 400 units wanted $8 per unit rather than the current cost of $7 per unit? Okay. So, again, we know that these 400 units, we can get them, but what if it costs an extra $1? Okay, so what would happen in that case is we see that our costs will be going up for the electronic components. Okay, and of course, with that, our profits are going to change as well. So we're going to look at our sensitivity report and figure out exactly what's going to change there. All right, so we're at our sensitivity report here, and I'm going to clear this out because we'll need a little bit of room to work here. All right, so our question said that if we wanted to change the amount of this from 4,700 to now 5,100, a difference of 400 units, what's going to happen there, okay? And in particular, what's going to happen if the cost goes from $7 to $8, okay? Well, we see here in the answer, well, in the sensitivity report that we see here, we know that there's going to be a change as far as the shadow price is concerned and the profits. However, the cost is going up. And so since the cost is going up by $1, that's actually going to change our objective function coefficients. So we need to go back a little further and see exactly how that's going to change the objective function coefficients. All right, so looking back to what we did when we first started off, what we see here is that if we wanted to basically change the price of the electronic components by $1, then you can see that for here we currently had 7. We changed this to 8. That's going to increase the cost of all of these items here. So in particular, we know that each MP3 player had electronic components, had 3 electronic components there. So that's going to increase the amount here by $3. For the non-electronic component, so for electronic components here, just price change of $3 in the cost. Okay, for the electronic components for the satellite radio tuner, we need 4 of them, so that's going to be a $4 increase. For the LCD TVs, again, that's going to be a $4 increase, and for the Blu-ray DVD player, that's going to be a $3 increase, okay, in the cost. And so we all see this because the difference in between 8 and 7 is 1, and we need 3 of the MP3 players, so that's 1 times 3 is 3. 1 times 4 is 4, 1 times 4 is 4, 1 times 3 is 3. So what that boils down to is that this profit is going to go down by 3, 4, 4, and 3 units respectively. So this is going to be down to 26. This will be down to 28. This one will be down to 68. And this one will be down to 51. Okay? So just kind of show you where it is. However, what we also realize here is that we're only making satellite radio tuners and Blu-ray DVD players. So all that we're really concerned about is the $4 difference in profit here. It's going down, and here the $3 difference in profit for the Blu-ray DVD player. Now, you'll remember that the LCD TV also has decrease in profit of $4, and the MP3 player also has a profit decrease of $3. However, we're not making any of those. So we're not really worried about that. And if we look at our sensitivity report again, you'll see that changing the 400 units is within the allowable increase and decrease. So here we know that we'll keep the same solutions. So since we'll keep the same solutions, and if we have $1 increase in cost of the electronic components, what that's basically doing is going to decrease profits again by $3 a unit for the satellite radio tuner, and it's going to decrease profit by $4 a unit for the Blu-ray DVD player. Okay, so at the end of the day, we know that we have profits total will be $3 a unit times, and of course the number of satellite radio tuners that we're making is 380. We also have $4 a unit, and that's going to be for the $1,060 we have for the Blu-ray DVD. And of course, multiply all that together here. Let's see, so we get the 380 times that, so that's 900 plus another $240. So that would be $1140 here, if my math is correct on that. And for the 1,060 units times the $4 a unit, that would be 4,000 plus another, looks like 60 times 4 is 240. So that would be 4,240 there. Okay, if I believe that's correct. Let me just check this just to be sure. So that's 0, that, 2, right. And so for the 380 times 3, got 0, 2, 9, 11. Yeah, so 1140. So if I take those two and add them up, I would get 5380. Oh, you know what? I did that wrong. I just realized that. So the 380 goes with the satellite radio tuner. Yeah, 380 goes with the satellite radio tuner, and that was $3 off. And the 1000 goes with the $4. Yeah, I think I got these mixed up here. So let's see. Let me go back just to check because I may have did that incorrect. Yep, so here for the satellite radio tune I had $4, and for the Blu-ray DVD I had $3. So I think I got those mixed up. Yep, satellite radio tuner should be $4. Yeah, I got those mixed up, so I apologize about that. So this should be 4 and this should be 3. Yep, so that's going to change things. So I'm about to do it again. All right. So this should be 4 and this should be 3, which means these values here are going to change. All right, so this is 3 and that's 4. All right, yeah, so of course all of this is going to change now. Yeah. So again, sorry about that, y'all. Put those numbers around. Okay, so now if we multiply 380 times 4, that's going to be 1200 plus another 320, which is going to be 1520, and 1060 times 3, that's going to be 3000 plus another 180. And if I add both of those up, I'll see that I'll get 4,700. Okay. And so this one, this would be the 1520. This would be the 3180. And of course, the total decrease in profit here is going to be $4,700. And so that will be the answer to question number 4. So decrease total profit $4,700. And of course we see that because again the additional 400 units at $1 more actually affects the price of the satellite radio tuners by $4 in profit, and for the Blu-ray DVD players by $3 profit. All right, so let's move on to the next set of questions. All right, so question number 5. Question number 5 says we want to assume that we have the opportunity to get an additional 250 hours of assembly time. Okay. However, it's going to cost us time and a half. Should we actually do this? And we'll go back to our sensitivity report here and see how adding those additional 250 hours, how that's going to affect us. All right, so we're at our sensitivity report here, and we see that we want to add 250 additional assembly hours. Okay. If we check the assembly time, we see that the amount for the allowable increase is 466.67. So this 250 definitely falls within the range to keep this the same. Now, after that, we see that by changing our assembly time by 1 unit is going to affect us at $24 increased profit. Now, the thing is, we're currently paying workers $10 an hour, okay? If we do time and a half, 50% of $10 is 5. So we're going to have to add an additional $5 an hour for that, okay? Now, of course, that extra $5 is taking away from our profit directly. So for each unit of assembly time we add on, we're going to have $24 in profit minus an additional $15 taken away from us because we're having to pay our workers time and a half. Okay, so effectively, what that comes out to be is a net gain of $9 an hour in profit by doing it. Now, if we take the $9 profit per unit there, and we multiply that times the 250, then we're going to get the amount of total profit we would get. And so, of course, that's 0. 9 times 5 is 45. Carry the 4. That'll be 2250, okay, or 2,250. So we see. Oh, sorry. That's yeah. That's 9. That's supposed to be 19. Yeah. Sorry about that. Messed that up there. All right. So here the $10 an hour is already built into this, but we have an additional 5 hours that's not built into it. So it should actually be $19. And so, of course, with 250 additional hours times the $19, this will turn out to be what we need to have here. And, of course, if I multiply this together, let's see, that's still 22, and then we have 250 down here. And so that's $4,750, okay? So we're seeing that we'll actually increase our profits by $4,750 if we pay our workers time and a half to produce any of these components that we're making, and in this case the satellite radio tuners and the Blu-ray DVD players. So we definitely should do it if we're trying to worry about whether we're going to lose money or not. Now, the only instance where you would not want to do this is if by making those changes, this doesn't meet the minimum profit amount that you would need to make in order for it to make sense for you. And so, for instance, if you want to make a change and you're saying, if we make a change in assembly time, we need to have at least $5,000 in additional profit, then of course this is not going to cut it. So what you would want to consider doing is either increasing the amount of assembly time available, or you may want to just jettison the whole idea, because you're saying, if I can only afford up to 250 additional hours, but it's not going to get me to that $5,000 goal, then it's not worth my time to do it. Okay. So in general, yes, we would do this because we're not losing money. But again, in real life, it would actually depend upon your situation and what your minimum acceptable profit or minimum ROI would be for making this change. All right, so let's go back to the questions. All right, so we're done with this question here. Question number 6 says, if we force the production of MP3 players, what would be the impact on total profit? Okay. Now, that one is easily answered by the reduced cost. So if we force the production of MP3 players, here the reduced cost tells us that for every unit, for every MP3 player unit that we produce, we're going to lose $1 in profit. Okay? So that's pretty much what that says. It's a pretty easy question to answer. All right, so here we just have decrease $1 in profit. Okay. So for every, well, that'll be per unit. So for every unit that we make, we have a decrease in profit. So that takes care of question number 6. Question number 7 says, how profitable must MP3 players be? Must MP3 players become before Anderson would consider producing them? So of course, we can also go back to our sensitivity report. And again, our reduced cost is telling us that we would have to, at the very least, get the profits up $1 more for us to consider producing this. So of course, if we add 1 to 29, that's going to be 30. So we need to be profits $30 or more in order for us to consider producing MP3 players. So that's what we'll do here. So greater than or equal to $30 profit. All right, so that answers question number 7. And so for question number 8, we want to assume that there is some uncertainty in the price of Blu-ray DVD players. And we want to figure out for what range of prices will the current production be optimal. Okay. And if Blu-ray DVD players were sold for $106, what would be Anderson's new total profit? So we'll handle question number 1 within this question first, which is for what range of prices will the current production be optimal? Meaning to make the same amount of DVD players we're making now, what range of prices will allow us to keep that same solution? Now, of course, our sensitivity report tells us that. So here, to keep this same amount, 1,060, we know that our range here is going to be $54, and here is our allowable increase and decrease, okay? So we know that our profits are allowed, and I'll just come down here. So this profit here is currently at 54. We're allowed to go up to $64, but only allowed to go down to $49. So what this means for us in terms of our current price, our price can either go up $10 or down $5 from where we currently are. If we look back at what our selling price is, we see that we're at $110. So coming back here, if we're saying that, then of course $110 plus 10 is going to give us 120. So that's going to be on the high end. And 110 minus 5 is going to give us 105 on the low end. So our range for selling the Blu-ray DVD players and still produce the 1,060 is going to be anywhere from 105 to 120. So that would be the answer to the first question there. Okay, so our range will be, price will be from 120 to 105. Okay. Now it says if the Blu-ray DVD player was sold for $106, then what would be Anderson's new total profit? So if we go back here, we'll see that the $106 price is okay because it's still within this range of 105 to 120. But of course, we're losing money at this point, right? So if we look at it in this way, then we see that the allowable decrease is $5. We're only going to go down from where we currently are to get to 106, so that's going to be $4. And if we change that, then we see that we'll be making $4 less per sale of each Blu-ray DVD player. Okay, so because of that, we know that there's going to be a decrease in $4. Okay, and we also know that we're selling 1,060 of them. So if we were to multiply 1,060 units times the $4 decrease in the amount of profit that we're going to get for each one, then of course we multiply all of this, we get 4240. So that would be the decrease in profit that we'll have. So by answering that last question there, we'll go back to it right quick. So if we were to reduce our price from $110 to $106, then the total profit loss is going to be down $4,240. And of course we see that because the difference in $4 here, just make that negative times the 1,060 units there. So that handles question number 8. So this is how we actually use sensitivity analysis reports and answer reports to be able to help us in doing what-if analysis on our current situation, and to see, all right, if we made these changes, will we be able to produce the same amount of items? If we wanted to consider producing other items that we're currently not producing, how much will that cost us? And so now we have a better idea of what kind of risk and what kind of flexibility that we have. Okay. All right. So moving on here, notice that all the questions that we talked about, we wanted to make one change. But what if we wanted to make simultaneous changes at the same time? So the 100% rule basically tells us that we can make those simultaneous changes, but what we have to do is make sure that the total amount of changes doesn't go over 100%. Because if we do that, then we're going to have to run a new model for it. But as long as the change that we implement, if there are multiple of them, as long as they are 100% or less, then we are good. And so we're going to look at an example of this to kind of see what we're talking about. And the changes that we're talking about are the right-hand side coefficients of the constraint inequalities or the objective function coefficients. So let's say, for instance, what we want to do here is we want to change our electronic components amounts from 4,700 to 4,200. Then of course you see here that that's a difference of 500 units, and that is a 52.63% change in our model by doing it. Okay, we see that our assembly time is 2,500 originally, and we want to increase that to 2,700. So in this instance, that's a 200-hour change, which is going to be a 42.85% change in our total model. And of course, if we add those up, we see that together that is a 95.48% change, which is less than 100% or 1, so we're good. Now, we're going to get into how we actually get these values here. We're going to go back to our sensitivity report and actually see how we calculate this. All right, so the first thing that we talked about was making a change in electronic components from 4,700 units to 4,200, which of course is a difference of 500. Now, first of all, when we look at the electronic components, we notice that the allowable decrease is 950. And of course, a decrease of 500 units falls within that. So how we get that is we actually say the difference in between what we want, which in this case is going to be the 500, and we divide that by the allowable decrease. And so that's how we actually got the 500 divided by 950, which gave us the 0.5263 or 52.63 percent change in our model. Similarly, we also talked about taking our assembly time and increasing that from 2,500 hours to 2,700 hours. Talking about here, we know that the allowable increase is 466.67 hours, so that fits within that. And so now the difference in between 2,500 and 2,700 is 200. So if we take that and divide it by the allowable increase, you see that's how we get the 200 divided by 466.67, and that is where we got the 42.85% change in our models. And of course, if we add these two numbers up, they come up to a probability of 0.9548, which translates to 95.48% change. So, of course, it's less than or equal to a 100% change, so we can make these simultaneous changes. All right, so now you see how we actually come up with those changes there. So let's move forward here. Now, if we wanted to change the objective coefficient, the selling price of the Blu-ray DVD player by -$3, and the satellite radio tuner selling price, we want to increase the objective coefficient by $5, then of course we see that the sum of the ratios here would be 0.8, or the 80% change. Now again, here for the Blu-ray DVD, we're going down $3 in profit. So that will change our profit by decreasing that objective coefficient by $3. And of course, with the satellite radio tuner, we'll be going up by $5 here. So I'll go back and show you how we calculate that as well. All right, so if we look at our objective function coefficients, we're looking in this column, and we want to decrease the Blu-ray DVD player by $3. So instead of saying 54 here, now we want to say 51. So we know that's a change in $3. And of course, the decrease here, total amount of decrease is $5. So we have the 3/5 change there, which is 0.6 or 60% change. Okay. Now we also said that for the satellite radio tuners, we wanted to increase the selling price by $5. And of course, this is going to make our profits go up with everything else being the same. So here, if we do that for the satellite radio tuners, if we go up $5, then that's going to change this to 37. And so now, if we talk about that difference is going to be $5, and our allowable increase here is 40. And let's see. So I think we had the satellite radio tuner going up $5. So that should be an increase of $5 over that, which should be 0.8. I'm sorry, 1/8, which is about 0.125. So not sure how we got the $8 change there in the slide. Yep, so let's go back here because I think I have something wrong here. Yep, so this should be $5 like that. And of course, this number here will be different because of that. So I don't know how that got to be that way. But yeah, 1/8 is about 0.125. This is 0.6. So this ends up being a 0.725 change there, which is still less than 1, so we can still do it. So not sure how that came about, but we can see how we can correct that now. Now, if we were to change this and say, instead of this being a $5 increase, let's say it's an $8 increase, then of course all of what we see here would be correct. So all this would be correct if that was $8. So we'll just go ahead and assume that this was a typo here, and we'll just let that be $8 so everything stays consistent there. But of course, if it was a $5 increase, like how I did before for the satellite radio tuners, then of course this would be the correct amount of simultaneous changes in terms of probability is concerned. All right. So here we're going to end on how do we actually price out new variables here. So let's say we're adding on to this example now, and what we want to do is come up with a situation where we want to add another product to the mix. So we want to do a digital home theater speaker system, okay? And of course, we see the number of electronic, non-electronic, and assembly components that we have. And we also see what the selling price is per particular unit. So if we want to add this to our situation here, then of course, if we look at this, the 5 is coming from the amount of electronic components that we have here. Of course, this is going to go with the 950, and then the 560, and then the 1325 here. So let's go back and kind of see where all this is coming from so that we can make better sense of it. All right, so if we look here, we know that if we're wanting to add our digital home theater speaker system to our product mix that we're trying to produce, then we know that from what we saw earlier that we're going to have an addition of 5 electronic components being used per one of these systems, an addition of 4 electronic components used, an addition of assembly time of 4 hours. Okay, so of course all these are additions, so we're going to use the allowable increase to figure out how much of a change we have. Now, we know that for the electronic components, we're going to have a change of 5, and of course our allowable increase, increase here is 2,800, allowable decrease is 950, okay? So what's actually going to happen here is if we add on this particular product, then we're taking away components from the other ones. So this is going to actually fit within the decrease model here, okay? And of course, for assembly time, we're taking away 4 hours from the other components. So that's why we would look here. And then for the the non-electronic components, we're taking away 4 components from here. So that's where the 4 divided by 560 comes from. And of course, we would add all these things together. And so now going back to where we were, all right, now you see why we have the 5 divided by 950 here. Let's try to do that again. And the 4 divided by 560, 4 divided by 1325. Okay. And of course, this again represents the electronic components. This represents the non-electronic components. and this represents the assembly time here, and the changes in that. And so we see that because of that, the required profit contribution is going to be 5 times whatever the shadow price is for the electronic component is, 4 times the shadow price for the non-electronic component, and 4 times the shadow price for the assembly time constraint. And of course, that's we actually have that because, again, we're using up 5 extra components, 5 extra electronic components, 4 extra non-electronic components, and 4 hours of assembly time that we would normally be dedicating to other products. So let's go back and make sure that we're following everything. All right, so before we do that, of course, remember here, this is the shadow price for the electronic components. Of course, for the non-electronic components, since we had some slack, there is no change in profit needed for that. And of course, here for the assembly time, we have a shadow price of $24 per change in the amount of units that we use. And of course, again, just to make sure that we understand here, here's that shadow price for the electronic components. So we're saying $2 per each additional 5 units. Here we have, move this out of the way. Here we have no shadow price because we had some slack for the non-electronic components. And we have $24 shadow price, or $24 in increase or decrease in profit based upon how many assembly hours we change. And of course, we're increasing this by 4, so we need that much additional to that, 4 times the 24. So let's go back to where we were. All right, so we see from making these changes here that the required profit contribution here is going to be $106. Okay. And if we move on here, we see that the actual cost of producing these items here is again going to be 5 times the shadow price, 4 times the shadow price for non-electronic components, and 4 times the shadow price for assembly time. Okay, and so again, if we look at this, well, actually this really shouldn't be the shadow price. It should be times just the price of the electronic components. So let's get rid of that, because we know the price for each electronic component was $7. The price for each non-electronic component was $5, and the price that we pay for assembly time is $10. So of course, if we have all of that, then we see that the cost plus the actual profits that we need to make in order for this to make sense for us to make is going to be $201. Okay? And so that would be our minimum selling price based upon the current availability of supply that we have, if we wanted to introduce a new product into our market. So of course, this is what it would look like if we actually introduced it in. And we see that at the selling price of $175, we're pricing ourselves out. Thus, we're not going to make any of these because we know that our minimum price here that we need to come up with to be able to make sense to even sell it, to make the kind of profit that we need, is going to be $201. So we've effectively priced ourselves out of making this particular product because we're not selling it for a large enough amount. And so we'll see here that we keep on just producing the satellite radio tuner and the Blu-ray DVD player. Okay? And the only way that we would want to produce this theater system here is if we could somehow sell it in the market to where the $201 or more would make sense and customers will buy it, or we can drastically reduce the cost of the electronic non-electronic and or assembly hours so that we can drive that cost down so our profit margins can increase. And of course, if we go to our sensitivity report here, we'll see that for the final value or final solution for the theater system, we're not going to produce any. And we see that that reduced cost there, or the opportunity cost, says that we need to somehow raise the price by $26 or reduce cost by $26 so that we can, so it can make sense for us to make this particular product here. And of course, you'll see that our shadow pricing is the same for this particular model because, again, we've decided at this particular price point of $175 for digital home theater system that it's just not worth making. Okay. All right, and so this concludes the presentation on sensitivity analysis, and in particular using sensitivity analysis reports to do what-if analysis on a situation to see how various things could change based upon what questions you have about your current model. So thank you for sticking in and watching this video. I know it's kind of long, but I hope it's informative. Take care.